Deep in the solar system, two monstrous worlds are generating unimaginable forces. Venus is a crushing furnace of carbon dioxide and sulfuric acid clouds hot enough to melt lead. Jupiter is a gas giant so massive it could swallow 1,300 Earths, surrounded by a magnetic field crackling with lethal radiation. But on the evening of June 9, these two planetary empires will mask their violent realities, aligning in our sky to form a spectacular, silent illusion. Two brilliant headlights almost close enough to touch. This is not a slow event that takes weeks to unfold. It is a sharp, urgent alignment that will peak and fade in a matter of hours. Millions of people will look west in confusion, searching the internet for satellite launches, weather balloons, or unidentified objects. Yet this viral phenomenon requires no telescope. It is a raw display of cosmic orbital speed, a precise line-of-sight crossover of Earth, Venus, and Jupiter. If you miss this brief sunset window, you miss the most dramatic planetary pairing of the year. Subscribe to Deep Space Signal. Let's decode the universe together. To understand what is happening on the evening of June 9th, we must first look at the solar system from a broader perspective. The celestial event we are witnessing is known as a planetary conjunction. In simple terms, a conjunction occurs when two or more celestial bodies appear close to each other in the sky when viewed from Earth. But this closeness is entirely a matter of perspective. The planets are not actually approaching one another in space. They are separated by millions of miles of empty vacuum. Think of it like standing on a street corner and looking at a distant streetlight while a friend walks between you and the lamp. From your position, your friend's head might appear to touch the bulb. In reality, they are separated by many yards. The same principle applies to Venus and Jupiter during this alignment. Earth, Venus, and Jupiter are moving along their respective orbits at different distances from the Sun and at different speeds. Venus is the second planet from the Sun, orbiting inside Earth's path, while Jupiter is the fifth planet, orbiting far out in the cold regions of the outer solar system. On June 9, these three planets will arrive at positions in their orbits that form a nearly straight line in space. When we look out from Earth, our line of sight passes directly past Venus and continues onward to meet Jupiter. Because we view the sky as a flat two-dimensional dome, we lose all sense of depth. The two planets appear to be side by side, almost touching even though they remain in their proper, distant orbits. This alignment is made possible because all the planets in our solar system orbit the Sun in roughly the same flat plane. This plane is called the ecliptic. As we look at the solar system from our position on Earth, we see the Sun, Moon, and planets travel along a single narrow path across the sky. If the planets orbited the Sun at wildly different angles, conjunctions would be incredibly rare. But because their orbits are nearly aligned with the plane of Earth's orbit, they constantly pass one another as they circle the Sun. However, because the orbits of Venus and Jupiter are tilted by a few degrees relative to Earth's orbit, they do not pass each other at the exact same height in the sky during every alignment. Most of the time they pass several degrees apart, looking like two distant neighbors. But on this specific night, the geometry is nearly perfect. The tilt of their orbits aligns in a way that minimizes their vertical separation, bringing them to within 1.6 degrees of each other. This alignment is a reminder of the vast scale of our solar system. Venus orbits the Sun at an average distance of about 67 million miles, while Jupiter is situated much farther out, averaging about 484 million miles from the Sun. When you look at them on this evening, you are looking across a gulf of space that is hard for the human mind to comprehend. The light from Venus takes only a few minutes to reach your eyes, while the light from Jupiter has traveled for over 40 minutes before finally hitting your retina. Yet, to our eyes, they are neighbors, sharing a tiny patch of the evening sky in a display of cosmic geometry. This is the beauty of a conjunction. It collapses the three-dimensional depth of the universe into a simple, elegant picture that anyone can appreciate from their backyard. The brighter of the 2 points of light you'll see in the west is Venus. To the ancient Greeks and Romans, this planet was the symbol of beauty, named after the goddess of love. It is not hard to see why. When Venus appears in the twilight, it shines with a steady, brilliant white light that easily outshines every star in the night sky. In fact, under perfect conditions in a dark location, Venus is bright enough to cast faint shadows on the ground. But the physical reality of this world is a stark contrast to its gentle appearance from Earth. Venus is often called Earth's twin sister because it is almost the same size and mass as our home planet. But that is where the similarities end. If you could step onto the surface of Venus, you would find yourself in a hellish environment. The surface temperature is hot enough to melt lead, hovering around 900 degrees Fahrenheit. The atmospheric pressure is 90 times greater than that of Earth, equivalent to the pressure found half a mile deep in the ocean. This crushing atmosphere is made almost entirely of carbon dioxide, which traps the sun's heat in a runaway greenhouse effect. This environment is so hostile that human spacecraft have struggled to survive there. During the space race, the Soviet Union sent a series of robotic landers called Venera to the Venusian surface. Most of these probes were crushed or fried within minutes of landing. The longest-lasting probe survived for only about 2 hours before its electronics melted and its instruments were destroyed by the intense heat and pressure. The images they sent back showed a flat, orange-tinted terrain covered in volcanic basalt rocks under a hazy, yellowish sky. But the main reason Venus shines so brightly in our sky is its clouds. The entire planet is permanently shrouded in a dense layer of clouds made of droplets of sulfuric acid. These clouds are highly reflective. In astronomy, the reflectivity of a celestial body is measured by its albedo. While Earth has an albedo of about 30%, reflecting less than a third of the sunlight that strikes it, Venus has an albedo of about 75%. This means that 3/4 of the sunlight hitting Venus is bounced back into space like a giant mirror. Because Venus orbits closer to the sun than Earth, we always see it near the sun in our sky. It never rises in the middle of the night. Instead, it appears either shortly after sunset in the west or shortly before sunrise in the east, earning it the names of the evening star and the morning star. During the conjunction on June 9, Venus will be brilliant in the evening twilight, drawing the eye immediately. This makes it about 15 times brighter than Sirius, the brightest star in the entire night sky. When you look at Venus during the event, you are looking at the ultimate cosmic paradox, a world of crushing pressure, acid rain, and volcanic heat transformed by distance and perspective into a brilliant, beautiful jewel hanging in our sky. The second point of light in the pair is Jupiter. While Venus is the brightest planet we can see, Jupiter is a close second. On the evening of June 9th, Jupiter will shine with a steady, cream-colored light that looks slightly warmer than the intense white glare of Venus. What makes Jupiter's brightness so remarkable is not its proximity, but its sheer size. Unlike Venus, which is relatively close to Earth, Jupiter is located in the cold outer regions of the solar system, hundreds of millions of miles away. To put this in perspective, if Venus were the size of a single grape, Earth would be a grape of the same size, but Jupiter would be the size of a large basketball. Jupiter is the largest planet in our solar system. It is so massive that all the other planets in the solar system could fit inside it with room to spare. More than 1,300 Earths could fit inside its volume. It contains more than twice the mass of all the other planets, moons, and asteroids in the solar system combined. Because of this colossal volume, Jupiter acts as a massive reflector of light. Sunlight travels from the center of the solar system, weakening as it crosses the millions of miles of space. By the time this light reaches Jupiter, it is only a fraction of the brightness that strikes Earth or Venus. But Jupiter has a vast surface area to catch this sunlight. Its atmosphere is made almost entirely of hydrogen and helium gas, but its upper layers are filled with clouds of ammonia ice crystals. These ammonia clouds reflect about 52% of the light that hits them. Deep beneath these colorful clouds, the pressure is so intense that the hydrogen gas is compressed into a state that cannot exist on Earth. Scientists believe that thousands of miles below the cloud tops, Jupiter has a massive ocean of liquid metallic hydrogen. This metallic ocean conducts electricity and is responsible for generating Jupiter's magnetic field, which is the largest structure in the solar system. This magnetic field is so powerful that it creates permanent glowing auroras at the planet's poles, visible only in the ultraviolet spectrum. This giant planet is also a historical turning point for human science. In January of 1610, the Italian astronomer Galileo Galilei pointed his newly built telescope at Jupiter. He noticed 4 tiny bright dots near the planet. Over several nights, he watched these dots move around the giant world, realizing that they were moons in orbit. This discovery proved that not everything in the universe orbited Earth, helping to dismantle the old geocentric model of the cosmos and launching the scientific revolution. On June 9th, Jupiter will be located far behind Venus in our line of sight. Yet because of its enormous size, it will appear almost equal in size to the naked eye, though slightly dimmer than Venus. Seeing them side by side is a visual collision of 2 planetary empires. brought together by a trick of perspective. The most fascinating aspect of the conjunction on June 9 is the illusion of proximity. When you look at the sky after sunset, your eyes will tell you that Venus and Jupiter are close neighbors. They will appear almost close enough to touch, separated by a distance that seems tiny compared to the rest of the night sky. But this is a trick of perspective. In reality, the two planets are separated by a vast gulf of space that is wider than the distance between Earth and the Sun. To understand the scale of this illusion, we must look at the actual distances involved. On June 9, Venus will be located roughly 75 million miles away from Earth. This is a considerable distance, but in astronomical terms, Venus is in our backyard. Jupiter, on the other hand, will be located much farther away, at a distance of approximately 450 million miles from Earth. This means that Jupiter is 6 times farther from us than Venus. The distance between Venus and Jupiter themselves is about 375 million miles. This is a vast, empty expanse of space. If you could travel at the speed of a commercial airliner, it would take you more than 70 years to cross the gap between these two worlds. We can also measure this distance in terms of the speed of light. Light is the fastest thing in the universe, traveling at 186,000 miles per second. Yet even at this speed, the differences in travel time are staggering. The sunlight reflecting off Venus takes only about 6.7 minutes to reach Earth. The sunlight reflecting off Jupiter, however, takes over 40 minutes to make the same journey. When you look at the two planets side by side, you are looking at two different moments in history. You see Venus as it was less than 7 minutes ago, but you see Jupiter as it was 40 minutes ago. This happens because the human eye has no way of perceiving depth when looking at the night sky. Our brains rely on depth cues to judge distances. We compare the size of known objects, or we use the slight difference in the views from our left and right eyes to create a three-dimensional model of our surroundings. If you hold your thumb at arm's length and close one eye, then switch eyes, your thumb will appear to jump against the background. This is called parallax. But for objects in space, they are so far away that parallax is imperceptible without highly sensitive scientific instruments. As a result, the brain projects all celestial objects onto a flat, two-dimensional sphere called the celestial dome. Stars, planets, and galaxies all appear to be at the exact same distance from us, stuck like glowing decals to the inside of a giant bowl. When two planets align along our line of sight, we only see their position on this flat dome. We see them move closer together, but we do not see the massive distance separating them in the third dimension. What looks like a close encounter between two cosmic neighbors is actually a chance alignment of two distant travelers separated by a vast expanse of empty space. When astronomers talk about the conjunction on June 9, they will describe the planets as being separated by about 1.6 degrees. To the average person, this number can sound abstract. How do we measure angles in the sky, and what does 1.6 degrees actually look like when we step outside to look? Fortunately, you do not need complex tools to understand this measurement. You can use your own body to measure the cosmos. Since ancient times, astronomers have used angular distance to describe how far apart objects appear on the celestial dome. Because the sky is a sphere, we measure distances across it in degrees, minutes, and seconds, just like a circle. A full circle around the horizon is 360 degrees, and the distance from the horizon straight up to the point directly overhead is 90 degrees. To measure smaller structures in the sky, astronomers divide each degree into 60 minutes of arc, or arc minutes. Each arc minute is further divided into 60 seconds of arc, or arc seconds. A separation of 1.6 degrees is equal to 96 arc minutes. To understand how small this is, consider that the limit of human vision, the smallest detail a person with normal eyesight can resolve without a telescope, is about 1 arc minute. Since Venus and Jupiter will be 96 times farther apart than this limit, they will appear as two distinct, brilliantly glowing points of light, not a single blurry dot. To visualize this on a smaller scale, you can use a simple trick with your hand. If you extend your arm fully and hold out your pinky finger, the width of your pinky at arm's length covers about 1 degree of the sky. If you hold up 2 fingers, it covers about 3 degrees. If you make a fist, the width of your fist covers about 10 degrees. And if you stretch out your hand, the distance from the tip of your thumb to the tip of your pinky covers about 25 degrees. During the conjunction on June 9, Venus and Jupiter will be separated by 1.6 degrees. This means the gap between them will be slightly wider than the width of your pinky finger held at arm's length. If you hold your pinky up to the sky, you will be able to cover both planets at the same time with room to spare. Another excellent way to visualize this distance is by comparing it to the moon. The full moon is one of the most familiar objects in the sky, but it is actually much smaller than most people realize. The angular diameter of the full moon is only about half a degree. This means that if you lined up full moons across the sky, it would take 360 of them to reach from one side of the horizon to the other. Because the full moon is half a degree wide, the 1.6 degree separation between Venus and Jupiter on June 9 is equivalent to just over 3 widths of the full moon. If you could place 3 full moons side by side in the sky, they would fit neatly into the gap between the 2 planets. This is a very close alignment, creating a striking pair of lights that will draw the eye immediately. It is this proximity that makes the event so visual and so accessible to anyone who looks up. For most of human history, a conjunction like the one on June 9 would not have been viewed as a simple scientific curiosity. It would have been seen as a sign from the gods, a warning of war, or a harbinger of great change. Before we understood the physical laws that govern the motion of the planets, the night sky was a canvas of myth and prophecy. The sudden appearance of 2 bright lights moving close together was a powerful event that could shape the course of history. Ancient cultures across the globe watched these alignments with a mixture of dread and reverence. The sight of 2 planets seemingly fusing into a single bright point of light was interpreted as physical message from the cosmos. Astrologers and early skywatchers did not see empty gas giants or acid-wrapped rocks. They saw gods and forces that dictated the fate of empires, looking for patterns that might predict plagues, wars, or the fall of kings. One of the most famous historical debates surrounding planetary alignments involves the search for the origin of the Star of Bethlehem. For centuries, theologians and astronomers have wondered what celestial event could have guided the Magi to the birthplace of Jesus. In the early 17th century, the great German astronomer Johannes Kepler proposed a scientific explanation. Kepler calculated that a series of rare conjunctions between Jupiter and Saturn had occurred in the year 7 before the Common Era. Later, astronomical calculations suggested an even more dramatic candidate. In the year 2 before the Common Era, Venus and Jupiter came so close together in the evening sky that to the naked eye, they would have appeared to merge completely, forming a single blinding point of light. To ancient observers, this union of the king planet and the morning star would have been a sign of immense significance, a symbol of transition that captured the imagination of the entire ancient world. By the time Kepler was studying the sky, the invention of the telescope was beginning to transform our understanding of the universe. Kepler used the precise observations of Tycho Brahe to formulate his 3 laws of planetary motion. These laws proved that the planets move in elliptical orbits around the sun, driven by physical forces rather than the whims of gods. Conjunctions were no longer viewed as supernatural portents, but as predictable results of orbital geometry. The celestial dome was no longer a canvas of gods, but a physical system governed by mathematics. Yet, even as the fear of celestial signs faded, our fascination with them remained. The conjunction on June 9 connects us to this long history of skygazing. When we stand in our backyards and look west at the 2 bright lights, we are seeing the exact same sight that inspired fear, wonder, and scientific discovery in our ancestors. We are participating in a human tradition that spans millennia, looking at the same cosmic headlights that have guided our curiosity since the dawn of civilization. If you want to witness this event for yourself, timing is the most critical factor. The conjunction of Venus and Jupiter on June 9 is easy to see, but the window of opportunity is relatively short. Because both planets are located in the western sky, they will follow the sun down and set below the horizon only a few hours after dark. To get the best view, you need to know exactly when and where to look. Your preparation should begin at sunset. Find a location with a clear, unobstructed view of the western horizon. Tall trees, buildings, or hills can easily block the planets because they will be hanging relatively low in the sky. As the sun sinks below the horizon, the sky will still be too bright to see most stars. But Venus is so bright that it will become visible in the twilight glow almost immediately. Within 15 to 20 minutes after sunset, you should be able to spot it as a bright white point of light. As the sky grows darker, Jupiter will begin to appear right next to Venus. The sweet spot for observation is between 45 minutes and 2 hours after local sunset. During this time, the sky will be dark enough for both planets to shine with maximum contrast, but they will still be high enough above the horizon to avoid the thickest layers of atmospheric haze. As the planets sink lower toward the horizon, you might notice them start to flicker or even change colors slightly. This is an atmospheric effect, because their light must travel through a thicker layer of Earth's atmosphere. When they are low on the horizon, the air distorts and bends the light rays. This causes a twinkling effect which is unusual for planets, as they normally shine with a steady, unblinking light. This twilight atmospheric distortion can add a dramatic, shimmering quality to the display. For those interested in capturing this moment, a modern smartphone is more than capable of taking a great photo. To get the best results, do not use the digital zoom, as this will only pixelate the image. Instead, mount your phone on a small tripod or rest it against a stable surface to avoid shaking. Use the manual exposure settings to lower the brightness slightly so that the planets do not appear as overexposed white blobs. If your phone has a night mode, let it run for a short exposure of 1 to 2 seconds to capture the twilight colors in the background while keeping the planets sharp. One of the best things about this conjunction is that you do not need to travel to a dark sky park or a remote wilderness area to enjoy it. Many astronomical events, such as meteor showers or faint comets, require pitch-black skies to be visible. But Venus and Jupiter are so bright that they can easily pierce through the light pollution of major cities. While you do not need any special equipment to see the conjunction, a simple pair of binoculars can enhance the experience. Through binoculars, Venus will remain a brilliant point, while Jupiter may reveal its tiny moons if the sky is steady and your hands are stable. You may be able to spot its 4 largest moons, Io, Europa, Ganymede, and Callisto, aligned in a neat line on either side of the giant planet. By about 2 hours after sunset, the 2 planets will be very low on the western horizon, and they will set shortly after. If you miss this window, you will have to wait for the next alignment. That is why planning ahead and stepping outside at the right time is so important. The conjunction of Venus and Jupiter is not a random coincidence. It is the result of a precise orbital choreography that has been repeating for billions of years. To understand why this alignment occurs on June 9, we must look at the mathematical laws that govern how planets move around the Sun. Every planet in our solar system follows a path dictated by gravity. According to the laws of planetary motion discovered by Johannes Kepler, these orbits are not perfect circles, but ellipses, with the Sun sitting at one focus. The speed at which a planet travels along its orbit is determined by its distance from the Sun. The closer a planet is to the Sun, the stronger the gravitational pull it experiences, and the faster it must move to avoid falling inward. Later, Sir Isaac Newton refined Kepler's work by introducing the law of universal gravitation. Newton showed that the force of gravity between 2 objects depends on their masses and the distance between them. In the solar system, the Sun's immense mass dominates everything. This means that a planet's speed is a direct reflection of its kinetic energy balancing the Sun's gravitational potential energy. Venus is located closer to the Sun than Earth, orbiting at an average distance of 67 million miles. Because of this proximity, Venus travels at a speed of about 22 miles per second, completing 1 full orbit around the Sun in just 225 Earth days. Earth, orbiting farther out, travels at about 18 miles per second and takes 365 days to complete its journey. Jupiter is situated much farther away in the cold outer regions of the solar system. Because it is so distant from the Sun's gravity, it moves much slower, traveling at only 8 miles per second. It takes Jupiter nearly 12 Earth years to complete a single orbit around the Sun. This difference in orbital speeds means that the layout of the solar system is constantly changing. From our perspective on Earth, the other planets appear to drift across the background of stars at different rates. Venus, moving quickly in the inner solar system, changes its position rapidly, appearing in our evening sky for a few months before disappearing and returning as a morning star. Jupiter, moving slowly in the outer solar system, drifts through a single constellation of the zodiac each year. As these planets move at their different speeds, they periodically align. From Earth's perspective, Venus will catch up to and pass Jupiter in the sky. This is what we call a synodic period, the time it takes for 2 celestial bodies to return to the same relative position in our sky. The synodic period of Venus and Jupiter is about 391 days. which means a conjunction of these two planets occurs roughly once every 13 months. But not all conjunctions are created equal. In many cases, the alignment occurs when the planets are too close to the sun in our sky, making them invisible in the daytime glare. In other cases, the alignment occurs when the planets are separated by a wide angle, making the event less dramatic. The conjunction on June 9 is special because it occurs when the planets are well placed in the evening sky, far enough from the sun to be seen in deep twilight, and exceptionally close together. It is a rare combination of orbital timing and geometry. While the conjunction of Venus and Jupiter is a beautiful visual event, these two worlds also play critical roles in the story of our own planet. They represent two opposite forces in the architecture of the solar system. One acts as our guardian, protecting Earth from cosmic catastrophe, while the other serves as a warning of what can happen when a planet's climate goes out of control. Jupiter is often referred to as the gravitational shield of the solar system. Because of its immense mass, Jupiter possesses a powerful gravitational field that influences everything in its vicinity. For a long time, the common scientific narrative was that this gravity acted as a giant cosmic vacuum cleaner, pulling in dangerous comets and asteroids or throwing them out of the solar system entirely. According to this view, Jupiter protected the inner rocky worlds from constant, devastating impacts that would have reset the biosphere. However, modern research shows that Jupiter's role is much more complex and dangerous. Its gravitational influence is a double-edged sword. While it does intercept and deflect many outer solar system comets, its powerful gravity also perturbs the orbits of asteroids in the main belt. This disruption can throw stable rocky bodies into new chaotic paths that cross Earth's orbit, sending potential threats directly toward the inner solar system. Instead of acting solely as a protector, Jupiter works as a massive gravitational engine of chaos. When comets from the Kuiper Belt or the distant Oort cloud plunge toward the sun, Jupiter can act as a giant sling, accelerating them to higher speeds and throwing them onto collision courses with Earth. The very force that sweeps the solar system clean can also reload the chamber, sending a barrage of rocky projectiles toward us. Venus, on the other hand, is a warning. In the early history of the solar system, Venus may once have had liquid water on its surface, along with a temperate climate and active geology. But because Venus is located closer to the sun, it received more solar energy. Over hundreds of millions of years, the liquid water began to evaporate, releasing water vapor into the air. Water vapor is a greenhouse gas, and as it built up, it trapped more heat, causing more water to evaporate. This process is known as a runaway greenhouse effect. Once the oceans were gone, the carbon dioxide trapped in the planet's rocks was baked out into the atmosphere, creating the thick, choking air we see today. The water vapor was lost to space, destroyed by solar radiation, leaving Venus a dry, hot wasteland. Studying Venus is essential for climate scientists on Earth. It is a laboratory that shows us what happens when greenhouse gases dominate a planet's atmosphere. It helps us understand the delicate balance that keeps Earth habitable and teaches us the limits of planetary resilience. When you look at Venus and Jupiter side by side on June 9, you are looking at two worlds that define our place in the universe. One is the complex guardian that plays a double game with our safety, while the other is the mirror that warns us of internal dangers. They are two cosmic sentinels, each telling a different part of the story of how Earth became the unique, living sanctuary we know today. Beyond the physics, math, and orbital mechanics, the alignment on June 9 represents a rare bridge between human curiosity and the deep cosmos. For a brief window, the mechanical operations of the solar system are laid bare to the naked eye. We are forced to confront the reality that we are not standing on a flat, static platform. We are passengers on a rocky sphere traveling through a vast, dynamic void. This visual proximity between Venus and Jupiter is not just a beautiful sight. It is a powerful tool for modern astrobiology in the search for extraterrestrial life. Astronomers look for similar conjunctions and transits in distant star systems. When planets in other solar systems align, they block out the light of their parent stars in predictable patterns. By studying these distant eclipses and alignments, space telescopes like the James Webb can analyze the light passing through their atmospheres, searching for chemical signatures of water, oxygen, methane, or even industrial pollutants. This method is known as transit spectroscopy. As a distant planet transits in front of its star, the star's light passes through the thin ring of the planet's atmosphere. The gas molecules in that atmosphere absorb specific wavelengths of light, leaving dark gaps in the spectrum. This creates a chemical barcode of the alien world, revealing its atmospheric composition without us ever having to travel there. Eclipses and planetary crossings are the primary keys we have to unlock the secrets of alien biospheres. When you look at the conjunction on June 9, you are witnessing the exact same physical principles that scientists use to decode the atmospheres of worlds orbiting stars thousands of light years away. The physics that governs the paths of Venus and Jupiter is universal. The same gravitational math applies to the billions of exoplanets drifting through the Milky Way. This connection to the wider cosmos is why celestial events capture our collective attention. In a modern world dominated by screens and artificial lights, we rarely look at the night sky. We live in cities where light pollution has erased the stars, disconnecting us from the environment that shaped human navigation, timekeeping, and storytelling for thousands of generations. The conjunction on June 9 is an opportunity to reclaim this connection. It requires no specialized training, no expensive telescope, and no remote travel. You only need to step outside, face west, and watch the two brightest objects in our sky interact. It is a simple, direct link to the universe, showing us that the solar system is alive, moving, and visible from our own backyards. As you stand in the twilight and watch the two headlights of the cosmos, you are participating in a shared human experience. Across the country, millions of other eyes will be focused on the exact same 2 points of light. It is a moment of quiet, collective observation, a brief pause in the noise of daily life to admire the elegant mechanics of the universe we call home. The most beautiful quality of the conjunction on June 9 is its brevity. The alignment is not a permanent fixture of our sky, but a transient event, a brief moment of cosmic symmetry that will disappear as quickly as it arrived. By the evening of June 10, the straight line in space will have broken, Venus will have moved farther along its fast path, and Jupiter will have lagged behind. The two cosmic headlights will begin to drift apart, and within a few weeks, they will be located in completely different parts of the sky. This transient nature is what makes astronomical events so precious. If Venus and Jupiter were always side by side, we would quickly grow used to the sight. It would become part of the background of our lives. Another detail we ignore as we rush through our days, but because it happens for only a single night, we are forced to value it. We must make the effort to step outside, to find the right location, and to look at the sky at the exact right moment. This brevity is a reflection of the wider universe. The cosmos is not static. Everything in it, from the smallest asteroid to the largest galaxy, is in a state of constant motion. The orbits of the planets are cycles of return, but they never repeat in the exact same way. Each alignment is unique, shaped by the slight tilts and speeds of the worlds involved. The conjunction on June 9 is a singular event, a moment in time that will never happen again in the exact same way. As you look up at the two bright lights on that evening, take a moment to reflect on the nature of this motion. You are standing on a planet that is spinning at over 1,000 miles per hour, rushing through space at 18 miles per second around a star that is orbiting the center of the galaxy at 500,000 miles per hour. The universe is a vast machine of gears and paths, and we are traveling along with it. The conjunction is a window into this movement. It is a moment when the silent, invisible mechanics of the solar system become visible to the naked eye. It is an opportunity to feel the spin of the Earth, the path of Venus, and the vast scale of Jupiter. It reminds us that our human lives, though brief, are connected to cycles that span billions of years. We are a way for the cosmos to know itself, observing its own geometry from this small blue outpost in the dark. So, mark your calendar for June 9th, 2026. Prepare your viewing spot, step outside after sunset, and watch the headlights of the cosmos align in a brief, elegant show of geometry and light. If you want to see how upcoming space missions like VERITAS to Venus or the Europa Clipper to Jupiter's icy moons will uncover the deepest secrets of these extreme worlds, subscribe to Deep Space Signal. Let's decode the universe together. Which of these two extreme worlds interests you the most? The toxic, crushing furnace of Venus or the colossal radioactive empire of Jupiter? Let me know in the comments below.